So question 1a, write 84 as a product of its prime factors. So let's go straight to the cheat sheet. What we are going to do, we are going to draw a prime factor tree. And something else to note, if you aren't familiar with this already, a prime number is a number only divisible by itself and 1. We have some examples there. So we're going to start the prime factor tree with 84. Now I like to get the 2's out of the way at the beginning, so we're going to have 2 and 42. 42 can be 2 and 21. And 21 we cannot divide by 2, but we can divide it by 3 and 7, which incidentally are both prime factors, which is great. So we have the 2, the 3, and the 7. So to express this as a product of its prime factors, we are going to have 2 multiplied by 2, multiplied by 3, multiplied by 7. Or if we want to put it in index form, we're going to have 2 squared multiplied by 3 multiplied by 7. So part B, find the lowest common multiple, the LCM, of 60 and 84. So if we go to the cheat sheet, we're going to do another prime factor tree for 60. And then for part 2, we're going to use a Venn diagram to find the lowest common multiple. Okay, so let's do a prime factor tree for 60. So again, I'm going to look for those 2's. It's going to be 2 and 30. And with the 30, you can find another 2 there. That's 2 and 15. With the 15, we can't find a 2, but we can find a 3, and we can find a 5. And again, this is great. They are both prime numbers. So we have the 2, the 3, and the 5 to give us, if we multiply those to give us 60. Now I'm going to draw a Venn diagram. And what I'm going to do in the middle of this Venn diagram, I'm going to look for the prime numbers that are in both 84 and 60. So we have the 2's twice, we have a 3, and then on the 84 side we only have the 7, and on the 60 side we only have the 5. And I'm just going to multiply all of these numbers together. So we're going to have 7 multiplied by the 2, multiplied by another 2, multiplied by 3, multiplied by 5. And if you do this on your calculator, that will give you a total of 420. Question 2, we have a universal set of values from 1 to 10. We have A, which are the even numbers, B, which are factors of 10. Part A, complete the Venn diagram for this information. So on the cheat sheet, we're going to ask which numbers are only even numbers for A, which numbers are only factors of 10 for B, which numbers intersect both A and B, and which numbers are neither A nor B. So for the even numbers, for A, we are going to have 2, 4, 6, 8, and 10. For B, the factors of 10, we are going to have 1 and 10, and 2 and 5. And now we are going to try and identify the numbers that are in A and B. So we are going to have 2 and 10, and this is going to be in the part where the Venn diagram intersects. Now we are going to identify the numbers only in A, the numbers only in B, and the numbers that don't appear in A or B. So a number is chosen at random from the universal set. Find the probability that this number is in the set A intersect B. And A intersect B is going to be this bit in the middle that I'm highlighted now in yellow. So the 2 and the 10 are going to appear in this A intersect B. So we know that there's going to be 2 numbers out of the original 10 numbers. So we can say that the probability is going to be 2 in 10. Question 3, Carlo puts tins into small boxes and into large boxes. He puts 6 tins into each small box. He puts 20 tins into each large box. Carlo puts a total of 3,000 tins into the boxes so that the number of tins in small boxes to the number of tins in large boxes are in the ratio 2 to 3. Carlo says that less than 30% of the boxes filled with tins are large boxes. Is Carlo correct? You must show all your working. So if we go to the cheat sheet, number 1, we're going to use this ratio 2 to 3 to split the 3,000 tins into parts. We're going to ask the question, how many tins per part? We're going to use this ratio again of 2 to 3 and the tins per part to find the number of small tins and the number of large tins. For part 4, we're going to find out how many boxes of small tins and how many boxes of large tins there are. We're going to find the percentage of large boxes, and then we're going to ask the question, is this more or is it less than 30%? So to begin with, we're going to use this ratio of 2 to 3. And if we add these two together, this is going to give us a total of 5 parts. And remember, there are 3,000 tins in total. So we are going to try and find out how many tins per part. So we're going to have 3,000 divided by 5, which is going to give us 600 tins per part. So we're going to use this ratio again of 2 small to 3 large to try and find out how many tins are in the small boxes, how many tins are in the large boxes. So we have 2 times 600 tins in the small, 3 times 600 tins in the large, to give us 1,200 tins in the small boxes and 1,800 tins in the large boxes. If you look in the question, it says 6 tins into each small box, 20 tins into each large box. So if we divide these up, it will tell us how many small boxes we have. So we have 1,200 tins divided by 6 tins is going to give us a total of 200 small boxes. And again, if we divide this up, we're going to have 1,800 tins divided by those 20 tins to give us a total, if we knock those zeros off and make it easier, to give us a total of 90 large boxes. And to find out if Carlo is correct, we need to find the percentage of large boxes. So we're going to have the 90 large boxes divided by the total small boxes plus the total large boxes, which is 200 plus 90, and then multiply the 100 to give you the percentage. So 90 over 290 multiplied by 100 is going to give you a percentage which you will need your calculator for. As you will see, it's going to be 31.03448 yada yada yada, which is going to give you 31.03% to 2 decimal places. And we must now ask the question, is Carlo correct? Well, I'm going to have to say no, because the percentage of large boxes are over 31%. So as 31.03% is greater than 30%, Carlo is incorrect. Question 4a, complete the table of values for y equals 5 minus x cubed. And we have this table of values right here. So if we go to the cheat sheet, we are going to use our calculators for speed here, and then we are going to plot the points. So if we put x equals minus 2 into the equation, we get y equals 13. X equals 0 gives us y equals 5. X equals 1 gives us y equals 4. And x equals 2 gives us y equals minus 3. Part B, on the grid below, draw the graph of y equals 5 minus x cubed for values of x from minus 2 to 2. So for the first value here, we have x equals minus 2, y equals 13. So we just find those values on the graph. The 13 will come in the middle of the 14 and the 12. X equals 1, y equals 6. We plot that point. X equals 0, y equals 5. Plot that point. X equals 1, y equals 4. And the final one, we have x equals 2, y equals minus 3. And again, minus 3 is in between minus 2 and minus 4. And now we just need a nice smooth curve to connect those points and complete the line. So question 5, we have this right angle triangle right here. Work out the value of x. Give your answer correct to 1 decimal place. So if we go to the cheat sheet, it's a right angle triangle. So we know here we need to use trigonometry. And at GCSE, you should be very familiar with this SOHCAHTOA, these triangle shapes, which I'm going to show you in a second. Okay, so we have this right angle triangle here, and inside the right angle triangle, we have an angle of 34 degrees. Then we have this length of x millimeters, which is going to be opposite this 34 degrees, or we're going to class this as O for opposite. And we have this 178 millimeter length which is the long length of the right angle triangle opposite the right angle. This is going to be the hypotenuse, or h, and this will always be the longest length of a right angle triangle. So given that we have the O and the H, we are going to use this SO triangle. So it's going to be sine 34 equals the opposite over hypotenuse. So it's going to be, the opposite is going to be x. The hypotenuse is going to be 178. And to get x on its own here, we need to multiply both sides by 178. And that is going to give us 178 sine 34 equals x. And if you put that in your calculator, you will get x equals 99.53633, and so on, which is going to give you x equals 99.5 to 1 decimal place. So question 6, we have the vector A, which is 3, 4. The vector B, which is 5, minus 2. Find 2A minus 3B as a column vector. So if we go to the cheat sheet, we want to multiply vector A by 2, and we want to multiply vector B by minus 3. So for 2A, it's going to be 2 multiplied by 3 over 4, minus this 3B. So that's going to be minus 3, and we have 5 minus 2 for this vector. And if we just work these out, that is going to be 2 multiplied by 3, which is going to give us 6. 2 multiplied by 4, which is going to give us 8. Minus, well, we have 3 multiplied by 5. It's going to be 15. 3 multiplied by minus 2 is going to give us minus 6. And now if we just look at the x values, we have 6 minus 15, which is going to give us minus 9. And then for the y values, we have 8 minus 6, which is going to be 8 plus 6, which is going to give us 14. And that is our answer. Question 7, the diagram shows a right angle triangle and a quarter circle, which you can see here. The right angle triangle ABC has angle ABC, which equals 90 degrees. The quarter circle has center C and has radius CB. Work out the area of the quarter circle. Give your answer correct to 3 significant figures. You must show all your working. So if we go to the cheat sheet, we are going to use Pythagoras' theorem to find CB. And remember that A squared plus B squared equals C squared. So A squared equals A squared plus B squared equals C squared. And remember, CB is the radius. The area of a circle, you should know this, is pi r squared. The area of a quarter circle is going to be, therefore, pi r squared divided by 4. So first of all, we need to find this length CB. I'm just going to call this x. So as this is not the hypotenuse, this is the hypotenuse, it's going to be x squared equals 9 squared, the longest length, subtract a smaller length to give us the other small length. So x squared is going to equal 9 squared is 81, minus 6 squared is going to be 36. So x squared is going to equal 45. X is going to equal root 45. I'm going to leave that like that for now. And if this is the radius, so it's CD, I'm just going to put that in to show you. I just changed to blue because we're working in terms of the circle. So pi r squared is the formula of the area of a circle. But if we divide it by 4, we can get the area of a quarter circle. So we're going to have pi, well, the radius is root 45 squared divided by 4. Well, root 45 squared is just going to be 45 pi divided by 4, which is going to give us 35.3429 and so on. So this does not round up, so I'm just going to put 35.3 meters squared. Question 8, Tariq buys a laptop. He gets a discount of 5% off the normal price. Tariq pays £551 for the laptop. Part A, work out the normal price of a laptop. So if we go to the cheat sheet, well, if we know that he has taken 5% off, this is going to be 95% of the normal price. So in order to get the full price, we're going to divide by 95 and then multiply by 100. So £551 is going to be 95% of the price. So therefore, what we need to do, again, like I said in the cheat sheet, we're going to divide by 95 and then multiply this by 100. And that is going to give us £580. So part B, Joan invests £6,000 in a savings account. The savings account pays compound interest at a rate of 2.4% for the first year, 1.7% for each extra year. Part B, work out the value of Joan's investment at the end of 3 years. So if we go to the cheat sheet, we have this really nice formula. It looks a little horrible, but it's very useful. We have A equals P, and then in brackets 1 plus R to the power of N, where A is the final amount, P is the principal amount, R is the interest rate, and N is the number of years. So after the first year, well, he has an interest of 2.4%. So we know that it's going to be 6,000 multiplied by 1.024 to the power of 1, or just on its own 1.024. And that is going to give us £6,144. Just change the color to red. So we could do this individually for year 2 and year 3, but I'm going to do this in one go. So it's going to be 2 years later, after year 1. So we know that the original price is going to be £6,144. We're going to multiply this by 1.017. This time it's going to be to the power of 2 because it's 2 years. And that is going to give us 6,354.671616, which if we round it up to the nearest penny is going to be £6,354.67. And you could just put 2 to the nearest penny. Question 9. Aisha recorded the heights in centimeters of some girls. She used her results to work out the information in this table, which we have here. Aisha drew this box plot for the information in the table. The box plot is not fully correct. And we have this box plot here, we have the table here. Write down the 2 things Aisha should do to make the box plot fully correct. So if we look at the cheat sheet, we want to compare the values of the table with the box plot. And a little something to remember here, the interquartile range, the IQR, is equal to the upper quartile minus the lower quartile. Okay, so she has the least height here of 142 centimeters. Well, I'm going to check. This is going to be this one here. It looks like these are going up in 1, so this one does look like it's correct. I'm happy with that. This one, she has the lower quartile of 154 centimeters. If that's 150, that's 1, 2, 3. Again, this one looks good. The lower quartile looks good. We have the median is 162 centimeters. Well, this one here looks like it's on 161. So the median is going to be wrong. This should be 161 centimeters. The range of 40 centimeters, this goes from 142 all the way to 182. I'm going to say that one is correct also. So we do not know at the moment what the upper quartile is. We know the lower quartile, we know the interquartile range. So we do have this formula of the interquartile range equals the upper quartile minus the lower quartile. So if I want to get the upper quartile on its own, I'm going to add the lower quartile to both sides. And that is going to give us the interquartile range plus the lower quartile equals the upper quartile. So the interquartile range here is 17. The lower quartile is 154. So that means that the upper quartile should be 171 centimeters. But if we look here, it looks like it's on 172. So the 2 things that I'm going to write, I'm going to say the upper quartile should be on 171 centimeters, not 172 centimeters. And number 2, the median should be on 162 centimeters, not 161 centimeters. Question 10a, simplify in brackets 1 over m squared to the power of 0. If we go to the cheat sheet, we're going to use the laws of exponents throughout this question. And for part A, we are going to use the power of 0 rule. If you're not familiar with what that is, it is this one. So we have the power of 0, for example, a to the power of 0 equals 1. Or we could have, let's say, 5 to the power of 0 equals 1. Anything to the power of 0 is 1. So therefore, it doesn't matter what's in these brackets, it's to the power of 0. So that is going to equal 1. Part B, simplify 8 in brackets x minus 4, and then all divided by x minus 4 squared. We go to the cheat sheet for part B, we're going to expand and cancel out. So we can't really, we can expand the top, but I'm not going to. I'm going to leave it in the bracket. But just so you can see what we are doing here, we have x minus 4 squared, so we're just going to put that out twice. And then it's quite simple just to cancel this out. Whatever we have on the top and on the bottom, we can cancel out. So therefore, the answer here is going to be 8 over x minus 4. Part C, simplify in brackets 3n to the power of 4, w squared all to the power of 3. And in this one, on C, we're going to use the power of a power rule. So if we look for the power of a power rule, if we have a to the power of x and then in brackets all to the power of y, we simply multiply this x and the y. So we are going to do the same here. So we have all of these numbers all to the power of 3, all multiplied by 3. So just to make this a bit simpler, I'm going to write this out. So we have, well, this 3 is the same as 3 to the power of 1, multiplied by n to the power of 4, multiplied by w squared, and this is all in brackets to the power of 3. Well, if we use this power of a power rule on the 3, so we have this 3 to the power of 1, this 1 is going to be multiplied by 3 to give us 3 cubed. And this n to the power of 4, well, this power of 4 is going to multiply again by 3 to give us n to the power of 12. And then again multiplied by the w squared, well, this to the power of 2, or squared, is going to be multiplied by 3 to give us w to the power of 6. And if we just simplify this down, well, 3 cubed is the same as 27. Then we have n to the power of 12, w to the power of 6. Question 11. Jack is in a restaurant. There are 5 starters, 8 main courses, and some desserts on the menu. Jack is going to choose 1 starter, 1 main course, and 1 dessert. He says there are 240 ways that he could choose his starter, his main course, and his dessert. Could Jack be correct? You must show how you get your answer. So if we look at the cheat sheet, we know that the starters multiplied by the main courses multiplied by the desserts should equal 240 if he is correct. And then we need to ask the question, well, is this possible? So from what Jack said, we have an equation that looks something like this. We would have the starter multiplied by the main, multiplied by the dessert, and there should be 240 combinations or 240 ways to find this. So we know that there are 5 starters. We know that there are 8 main courses. We don't know how many desserts, and he says that there are 240 combinations. So we know that 5 multiplied by 8 is 40, multiplied by the d is going to be 40d equals 240. So if we divide both sides by 40, that leaves us with d on its own, and 240 divided by 40, which gives us 6. So therefore Jack could be correct if there are 6 desserts on the menu. Question 12, the graph gives information about the volume, V litres, of petrol in the tank of Jim's car after it has travelled a distance of d kilometres. And we have this graph right here. Part A, find the gradient of the graph. So if we go to the cheat sheet, well, if we want to find the gradient is going to be the difference in y divided by the difference in x. We're going to choose a sensible area of the graph to find the gradient. And part 3, what story does the gradient tell us about the litres of petrol and the distance in kilometres? So I decided to choose this point here for the gradient on the graph. It's because it's in between 100 here and 200, which gives us a value of 100 for here, which is nice, but also because they go through a very clear point at both sides. So we know that this one is going to, it starts off at 9, and it goes all the way up to 18. So that means that we know that this length here is going to be 9. This y value is going to be 9. So when it comes to the gradient, we know that the gradient is the difference in y divided by the difference in x. Well, the y value is going to be 9. The x value is going to be 100. And just to simplify this a bit more, so the gradient is going to equal 0.09. Part B, interpret what the gradient of the graph represents. So I put each kilometre travelled reduces the volume of petrol by 0.09 litres. When you do this, try and tell the story of what is going on and try and use the values that they give you. For example, they use litres of petrol and the distances in kilometres. Try and put those in your answer. Question 13, here is a triangle ABC, which you have this triangle right here. Work out the length of AB. This one here, let's just call it X. Give your answer correct to 1 decimal place. Okay. So if we go to the cheat sheet, well, this is a non-right angle triangle, so we cannot use SOHCAHTOA in this. We could possibly use the sine rule, we could possibly use the cosine rule. And something quite easy and useful to remember is all angles inside a triangle add up to 180 degrees. And I'm going to begin with that now. So if you can see this angle here, this angle CAB, well, we're given the other 2 angles in the triangle, which is 34 degrees and 26 degrees. So we can use this to find the angle here at CAB. So we can say the angle CAB, it's going to be equals 180 degrees, the total of the angles in a triangle. Subtract 34 degrees, subtract 26 degrees, and that is going to give us 120 degrees. And if we just give a reason here, so we could say all angles in a triangle add up to 180 degrees. So remember with the sine rule, we have, it's going to be A over sine A equals B over sine B. So what we are looking for is the angle and the opposite length. So for example, here we have 120 degrees at A, and the opposite length is going to be 23.8. And if we want to find out this x, we need to find the opposite angle. So we have 3 of the 4 pieces of information that we need to find x, and this is great. So therefore we can use the sine rule. So we have x over sine 34 equals 23.8 over its opposite angle, sine 120. So if we multiply both sides by sine 34, this allows us to get x on its own. So we're going to have 23.8 sine 34 divided by sine 120. That is going to give us x equals 15.3676 and so on. And to 1 decimal place, it's going to be 15, and we just round up here, so it's going to be 15.4 centimeters. Question 14, here are 2 squares, A and B. The length of each side of square B is 4 centimeters greater than the length of each side of square A. The area of square B is 70 centimeters squared greater than the area of square A. Find the area of square B. Give your answer correct to 3 significant figures. You must show all of your working. So if we look at the cheat sheet, number 1, this is my personal rule, just draw. Sometimes you can't visualize the answer, but if you just draw something, it can help you. So make sure you do that. Part 2, find 2 different values of the area of B in terms of x. Part 3, we're going to find what x is. And then part 4, we're going to use x to find the area of B. So if we look here, it says the length of each side of square B is 4 centimeters greater than the length of each side of square A. So I'm going to call this side x, and I'm going to put this in blue, and I'm going to call this side, I'm going to call this x plus 4. And if this side is x, well, all of the other sides are going to be x, and same with if this is x plus 4, this is also going to be x plus 4. So from this, we can say that the area of A is going to be x by x, so the area is going to be x squared, and the area of B is going to be x plus 4 squared. So it tells us here that the area of square B is 70 centimeters squared greater than the area of square A. Well, we know that the area of square A is x squared. So for the area of B, well, we know that the area of A is x squared. And it tells us here that square B is 70 centimeters squared greater than the area of square A, so we can put plus 70. So now we have 2 values for the area of B. We have this one here, and we have this one here. So as these are both equations for the area of B, we can say that they are the same. They equal exactly the same. So we can say that x plus 4 squared equals x squared plus 70. And if we expand these brackets, so we are left with x squared plus 8x plus 16 equals x squared plus 70. Just move this up. I'm going to subtract x squared from both sides. I'm going to subtract 16 from both sides. I'm going to divide both sides by 8. And now we have a value for x. So we can take our pick now. We have two values for the area of B. And I'm going to sub this value of 6.75 for x into one of these equations. And I'm going to choose this one. So the area of B is x squared plus 70 from here. And we know that x equals 6.75. So we're going to say 6.75 squared plus 70. That is going to give us 115.5625. But it does say in the question we need to give it to three significant figures. So this is going to round up to 116 centimeters squared. Okay, so question 15. We've got two triangles here, triangle A, triangle B. Describe fully the single transformation that maps triangle A onto triangle B. So if we go to the cheat sheet, the question we want to ask here is, does A increase or decrease in size, which would suggest that it is an enlargement. And if you want to pause the video to get an idea of what an enlargement is, feel free. And also possibly quite relevant for this question, we have negative enlargements. You might want to pause the video to have a little look at this slide. Okay, so we can see that triangle A is not the same size as triangle B, so therefore this suggests to me that this is an enlargement. And when it comes to the scale factor, well, we can see here on this side of A, this side is going to be 2. This side here, this corresponding side on triangle B, is going to be 3, which would suggest it is a scale factor of 3 over 2, or 1.5. However, we also need to take into account that this triangle A has been flipped, which means that this scale factor is going to be negative. So it's going to be a scale factor of negative 1.5. So now all that's left is to find the center of enlargement. I've deliberately put some colors on these triangles because these are the corresponding corners of the triangle. So for example, you have the blue with the blue, the green with the green, the yellow with the yellow. And all we have to do is join up these points with a straight line. So I'm going to go from yellow to yellow. And I'm going to go from green to green. And can you see if I put this in red here, we have this point here. And this point here is the center of enlargement. And just on a bit of a side note, if your center of enlargement is in the middle, like this, it generally means that the enlargement has a negative scale factor. So to answer the question, to describe fully the single transformation that maps triangle A onto triangle B, it's an enlargement with a scale factor of minus 1.5 from the point 1, 1. Question 16, here are the first 5 terms of a quadratic sequence. We've got 10, 21, 38, 61, 90. Find an expression in terms of n for the 9th term of this sequence. So we go to the cheat sheet. There are a few ways of doing this, but this is the really easy and quick way that I like to do it. So for your first term, this is going to equal A plus B plus C. Your first difference is going to equal 3A plus B. And your second difference is going to equal 2A. And a quadratic sequence looks like this. So we have a n squared plus bn plus c. Okay, so straight away I'm going to identify that the first term in the sequence is 10. Now we need to find the first differences. So between 10 and 21, this is going to be 11. Between 21 and 38, this is going to be 17. Between 38 and 61, this is going to be 23. And between 61 and 90, this one is going to be 29. And our first difference here is 11. And for our second difference, if we've done it correctly, these should all be the same. Well, the difference between 11 and 17 is going to be 6. The difference between 17 and 23 is going to be 6. The difference between 23 and 29 is also going to be 6. So the second difference is going to be 6. So we can now use these formulae to try and find out what A, B, and C are going to equal. So we know that for the first term that A plus B plus C is going to equal 10. We know that for the first difference, it's going to be 3A plus B is going to equal 11. And we know that for the second difference, 2A is going to equal 6. And we can do this very quickly. So 2A equals 6, well, we know that A is going to equal 3. And if we sub 3 in for A here, this is going to be 9 plus B equals 11. So we know that B is going to equal 2. And if we sub A equals 3 and B equals 2 into this equation, so we have 3 plus 2 plus C equals 10. So that is 5 plus C equals 10. Well, we know that C is going to equal 5. So we need to be using this form, this an squared plus bn plus c. So we're just going to sub these values into the equation to get the quadratic sequence. So a is going to be 3. It's going to be 3n squared plus bn will be is 2. So this is going to be plus 2n plus c. Well, c equals 5. So this is going to be 5. Question 17. Write down the coordinates of the turning point on the graph of y equals, and in brackets, x plus 12 squared minus 7. So if we go to the cheat sheet, any of the action inside the bracket, this is going to be something that's going to affect the x coordinate, but it's going to do the exact opposite of what we think. And any action that is outside of the bracket is going to affect the y coordinate, and it's going to do exactly what we think. So I'm going to start with that one. I'm going to start with the y coordinate. We have this minus 7. It's outside of the bracket. So we can say that y is going to be minus 7. It's going to do exactly what we think. It's going to subtract 7. And if I do this in blue, well, in the bracket, we have this plus 12 inside the bracket. So this is going to affect x, but it's going to do the exact opposite of what we think it's going to do. So instead of adding 12 to x, it's going to subtract 12 to x. Question 18. The diagram represents a solid cone, and we have that cone here. The cone has a base diameter of 20 centimeters and a slant height of 25 centimeters. A circle is drawn around the surface of the cone at a slant height of 10 centimeters above the base. The curved surface of the cone above the circle is painted grey. Work out the area of the curved surface of the cone that is not painted grey. Give your answer as a multiple of pi. You must show all your working. And we have this formula here. So if you want to find the curved surface area of a cone, it is going to be pi multiplied by the radius multiplied by L, which is the slant height. So if we go to the cheat sheet, what we are trying to work out here, for the area that is not grey, we want to find the total area minus the grey area. Something I'm sure that you know, but I'll tell you anyway, is the radius is going to equal the diameter divided by 2. And part 3, similar triangles are proportional. Use this to find the slant height of the grey cone. So for the question, we have the surface area not grey. It's going to equal the total surface area. Subtract this grey surface area right here. So we are going to use this formula, this pi r L. So for the total surface area, we know that, we have pi. So this cone has a base diameter of 20 centimeters. So if the diameter is 20, then the radius must equal 10. And now we need to multiply by L, which L is going to be the slant height. Well, the slant height of this cone is going to be 25. So we have pi multiplied by 10 multiplied by 25, and that is going to give us 250 pi. And same again for the grey surface area. We need to use this formula again, this pi multiplied by the radius multiplied by L. So I've just taken the time in red to draw this right angle of the full size of the cone, and then this blue angle, which is proportional but smaller. So we know that the slant height here is going to be this 25 centimeters, subtract this 10 centimeters. So we know this is going to be 15. Let's just show our working here. So we have 25 minus 10 is 15. But this radius here at the bottom, we still don't know. But we do know that the slant height of the larger cone is 25, and the slant height of the grey part of the cone is 15. So we can say that the ratio here is going to be 25 to 15, or you could say 5 to 3. So what we're going to do here with this 10, this radius here, we want to make it smaller, but proportionally smaller. So we're going to divide it by 5, and then multiply it by 3. So we're going to say 10 divided by 5, multiplied by 3. Well, 10 divided by 5 is going to be 2. 2 multiplied by 3 is going to be 6. So we are going to put this 6 here. So now we have our radius. So now for the grey surface area, we're going to use this formula again, this pi multiplied by r multiplied by L. So we have pi. And then now we can use this 6 as our radius. And for the slant height, we have this 15. 6 multiplied by 15, well, that is going to be 90. And then multiplied by pi is going to be 90 pi. So 250 pi minus 90 pi is going to give us 160 pi. And don't forget your centimeters squared. Question 19. A hot air balloon is descending. The height of the balloon n minutes after it starts to descend is h n meters. The height of the balloon n plus 1 minutes after it starts to descend, h n plus 1 meters, is given by h, this is hard to say, h n plus 1 equals k multiplied by h n plus 20, where k is a constant. The balloon starts to descend from a height of 1,200 meters at 9:15. At 9:16, the height of the balloon is 1,040 meters. Work out the height of the balloon at 9:80. So if we go to the cheat sheet, when no minutes have passed, when we have h0, this is going to be at 9:15. After 1 minute has passed, it's going to be 9:16. After 2 minutes, 9:17. After 3 minutes, 9:18. We are going to find the constant, k, and we're going to go through each minute individually until we get to 9:18. Okay, so I'll put this little box in as a bit of a guideline. So when it starts to descend at hn, this is going to be 9:15. After another minute, it's going to be 9:16. After 2 minutes, 9:17. After 3 minutes, 9:18. So we've got this formula. So we're looking for hn plus 1. Well, we know that that is going to equal 9:16. And we're going to find this out by using 9:15 and multiplying it by this constant and adding 20. So what is the value of hn plus 1? Or at the time 9:16, that is going to be 1,040. So I'm going to put that in there. We don't know k yet, but we do know what hn is because hn is 9:15, and at 9:15, that is at a height of 1,200. So we're going to subtract 20 from both sides. and then divide both sides by 1,200. And now we have the constant, and we can use that throughout the rest of this question. So now we want to find the height at 917, and to do that we're going to use the height at 916 and the constant in order to do this. So we know the constant is 0.85. We know that the height at 916 was 1040, and then we add the 20, and that is going to give us 904 meters. And we're going to use this here, over here, to find the height at 918. So again, we know the constant is 0.85. We know the height at 917 was 904, so we multiply by 904, and we add the 20. And that is going to give us 788.4 meters. Question 20, there are only red sweets and yellow sweets in a bag. There are n red sweets in the bag, there are 8 yellow sweets in the bag. Sajid is going to take at random a sweet from the bag and eat it. He says the probability that the sweet will be red is 7 out of 10. Show why the probability cannot be 7 out of 10. Okay. So we have two probabilities for red in two forms, let's say. So the probability of red, if we are thinking that there are n amount of sweets that are red, well, the total is going to be red over red plus yellow, which is why here we're going to have n divided by n plus 8. So r plus y, red plus yellow, is going to be the total. And we're also given nice and simple another probability that it will be red is 7 over 10. So the probability of red, well, we're given this in the question here, it says 7 out of 10. But also, the probability of red is going to be, well, we have n number of red sweets. So if we pick one out of the bag, it's going to be n over, it's going to be n. And how many yellow sweets do we have? We have 8. So it's going to be, the probability of red will be n over n plus 8. So now we have two probabilities of red. So we have 7 over 10 is exactly the same as n over n plus 8. So now we are going to cross multiply. So 7 multiplied by n plus 8, and let's say 10n. So that's going to be 7n plus 56 equals 10n. I'll just bring this down a little bit. So we are going to subtract 7n from both sides. And divide both sides by 3. And if you do this on your calculator, you are going to get n equals 18.6 recurring. So as n is not a whole number, the probability of red cannot be 7 out of 10. After Sajid has taken the first sweet from the bag and eaten it, he is going to take at random a second sweet from the bag. Given that the probability that both the sweets he takes will be red is 3 out of 5, part B, work out the number of red sweets in the bag. You must show all your working. So if we go to the cheat sheet, we are going to draw a probability tree first of all. This is going to really help us out a lot. Second part, well, the probability of picking a red and then picking another red, it's going to be the first pick multiplied by the second pick, and that is going to give us, as it gives us in the question, that is going to give us 3 out of 5. We're going to cross multiply to work out the value of n, and then we're going to ask the question, well, can n be negative? So I've just drawn this probability tree here, and if you remember from the first question, the probability of red on the first go is going to be n over n plus 8, because there are n amount of red sweets and there are 8 yellow sweets. Well, the second pick, bear in mind that he has just eaten the red sweet. Well, on the top, it's going to be n minus 1, because we have one less red sweet. We don't know the number, but we know it's going to be one less than the first go. And on the second go, again, this n is we're going to subtract 1 from this n, because he has eaten that red sweet. So it's going to be 1 less red, but still there's going to be 8 yellow. And the probability of getting a red and then a red, it is given in this question. I'll just circle it in the color red. It's going to be 3 out of 5. So when it comes to picking two reds, we're going to have this first pick here, multiplied by the second pick, which is here, is going to give us 3 out of 5. So I'm just going to put these values in. So we have n over n plus 8. We can't really do much with that at the moment. The second one, we have n minus 1 on the top. Can't really do anything there. But on the bottom, we have n minus 1 plus 8. Well, I'm just going to put these two together. So we are going to have n plus 7. And that is going to equal 3 out of 5. So we're going to multiply the numerators together to give us n multiplied by n minus 1. And multiply the denominators together. So it's going to be n plus 8 multiplied by n plus 7. So n multiplied by n is going to be n squared. N multiplied by minus 1 is minus n. N multiplied by n is n squared. N multiplied by 7 is going to be plus 7n. Plus 8 multiplied by n is going to be plus 8n. 8 multiplied by 7 is going to be plus 56. And that is going to equal 3 out of 5. Just move this up. And now we just need to tidy this up a bit. So we're going to add the 7n and the 8n together to give you 15n. So now we're going to cross multiply, and I'm just going to change the color to green to make it a bit more obvious. So we are going to have 5 multiplied by n squared minus n. and that this is going to be multiplied by the 3 to give us 3 multiplied by n squared plus 15n plus 56. 5 multiplied by n squared is going to be 5n squared. 5 multiplied by minus n is going to be minus 5n. 3 multiplied by n squared is going to be 3n squared. 3 multiplied by 15n is going to be plus 45n. And 3 multiplied by 56 is going to be 168. I'm going to subtract 3n squared from both sides. It's going to have 2n squared minus 5n on this side. That's going to get rid of that 3n squared on this side to give us 45n plus 168. I'm going to add 5n to both sides to give us 2n squared on this side, so there, that's going to cancel out. That's going to be 50n plus 168. Now I'm going to subtract 50n and 168 from both sides to give us 2n squared minus 50n minus 168 equals 0. I'm going to divide both sides by 2. To give us n squared minus 25n minus 84 equals 0. So to factorize, we need two numbers that are going to multiply together to give minus 84 and add together to give minus 25. This is going to be minus 28 and plus 3. So we are going to have, I'm going to change the color again. Let's change it to blue. We're going to have n minus 28 equals 0, or n plus 3 equals 0. I'm going to add 28 to both sides to give us n equals 28. It's one value for n. And here, I'm going to subtract 3 from both sides. And that is going to give us n equals minus 3. But remember, n is the amount of red sweets, and therefore cannot be negative. So therefore the answer is going to be n equals 28, and this n equals minus 3. We just forget about it, we cancel it. Okay, question 21. The graph of the curve of the equation y equals f of x is shown in the grid below, just here. Part A, on the grid above, sketch the graph of the curve of the equation y equals f of minus x. So if we look at the cheat sheet, when y equals f of minus x, this is going to be a reflection in the y-axis. So for example, this is the y-axis right here. So we're going to reflect. It's going to be like a mirror image. So this point here, it's going to be minus 1 to 2. Well, we are going to put it just here. And again, this point here, it goes 3 along to the left, and it's going to go 3 along to the right. And this point here is it goes along 4, so it's going to go another along 4 here. And then we just need to draw the graph. Okay, we've got two curves here. We've got curve C and we've got curve S. The curve C with equation y equals 5 plus 2x minus x squared is transformed to give the curve S, such as the point 1, 6, which is here, on C, is mapped to the point 4, 6 on S. Part B, find an equation for S. So we've already had a question like this before, but if we look at the cheat sheet, if the action is inside the bracket, it's going to affect x, and it's going to do the opposite of what we think it's going to do. If it's outside of this bracket, it's going to affect the y coordinate, and it's going to do exactly what we think. So if you can see here, the y coordinates, if I just point to those 6s there, those y coordinates haven't changed. So whatever we do to this, that y coordinate is going to do nothing. However, if we look at the x coordinate, well, on C, we know that the x coordinate is 1, and on S, the x coordinate is 4. So if it affects x, it's going to do something inside the bracket, but it's going to do the opposite of what we think. So because this is we are adding 3 to this total, when it comes to what we are going to do inside the bracket, we are going to do the opposite. We are going to subtract 3. So if C is y equals 5 plus 2x minus x squared, for S, we are just going to change every x value that we have. We are going to change it for x minus 3, not x plus 3, x minus 3. And here is our answer. Question 22. C is a circle with center at the origin, which is going to be 0, 0. A tangent to C passes through the points minus 20, 0, and 0, 10. Work out an equation of C. You must show all of your working. So we need to find an equation for C, the circle. If we look at the cheat sheet, we are going to draw what we are given, because trust me, it does help you. Find an equation of the tangent. And to find an equation, we're going to need the gradient and one set of coordinates. Part 3, we're going to find an equation of the radius. And again, we need the gradient and one set of coordinates, or an equation of a line. And number 4, the tangent and the radius are going to intersect on the circumference of the circle. This helps us to find the length of the radius. And we're going to bear in mind that the equation for a circle with the center at the origin is going to be x squared plus y squared equals r squared. This is going to be a long question, so I've just drawn some useful formulae on the side here. So we've got the equation of a circle here, the equation of a line, and what we would need a gradient and one set of coordinates on the line. We have the formula for a gradient of a line, which is going to be the difference in y over the difference in x, and we're going to need 2 points on the line in order to find this. And then we've got the gradients of perpendicular lines, which is going to be the first gradient multiplied by the perpendicular gradient is going to give you a total of minus 1. in the question it says a tangent to C passes through the points -20, 0. So plotted that point there, and 0, 10, and I plotted that point there, and I drew the tangent. Like I say, this really does help you a lot. So to begin with, I'm going to try and find the equation of this tangent, the equation of the line of this tangent right here. So the equation of a line, we're going to use this formula here. So it's going to be y minus y1 equals m, and then in brackets x minus x1. So we need to put this to work. We need a gradient of the line, which we don't have at the moment, which is why I have this question mark right here. But we do need to find one set of coordinates on the line. But fortunately, in the question, we have 2 points on the line. We know that this -20, 0 right here is on the line, and we know that this 0, 10 right here is on the line. And if you can say, you can take your pick. You could choose either of these coordinates. It really doesn't matter. But I've just decided to choose this 0, 10. So for x1, I'm going to have 0. y1, I'm going to have 10. So what we need to do, we need to find the gradient. Well, if we want to find the gradient of a line, we need 2 points on the line. We need the difference in y divided by the difference in x. And again, fortunately from the question, we have 2 points on the line already. So from the question, like I said, we are given 2 points on the tangent, which is great. We can use this to find the gradient. So I've just added these 2 points in here. So we have x1, y1, which is 0, 10, and x2 minus 20, y2 is 0. So let's just work this out now. So y2 is going to be 0, minus the y1, which is 10, all divided by x2, which is minus 20. A lot of negatives here, but it's okay. Minus the x1, which is 0. 0 minus 10 is minus 10. Minus 20 minus 0 is going to be minus 20. And a minus divided by minus is going to be a plus. 10 divided by 20 is just the same as 1 over 2. So in our little coordinate section here with the gradient, I'm just going to change this from a question mark into a half because we've just found this out. So now we're going to go back to this equation. If I just move this up a little bit more, we're going to go back to this equation of a tangent. So we have y minus y1 equals m x minus x1. So y minus y1, so y minus 10 equals, well, m is going to be a half. X minus, well, x1 is going to be 0. So we're going to have y minus 10 equals a half x. And then a half multiplied by minus 0 is just going to be 0, so we just leave that blank. I'm going to add 10 to both sides. And there we have this formula of the equation of the line of the tangent. So like I said on the cheat sheet, we really want to draw everything we have. So we know that this line of the tangent is going to be y equals a half x plus 10. So now we want to find an equation of the radius that is going to be perpendicular to this tangent at a 90-degree angle. Well, again, we do have a point on the, we need a point on the line, and we do have that. Well, we know that the radius is going to pass through the center point, which is just going to be 0, 0. So for our x1 coordinate, it's going to be 0, but our y1 coordinate, it's going to be 0. But we don't know the gradient yet. But we can use this here. We have the gradients of perpendicular lines, so we have the tangent and the radius, they are perpendicular. And we're going to use this formula. So the gradient of the tangent multiplied by the gradient of the radius is going to equal minus 1. So I'm just going to put that there. So we're going to have m1 multiplied by m2 equals minus 1. Well, we know the gradient from the tangent for this m1. It is going to be a half. So it's going to be a half multiplied by m2 equals minus 1. And that is going to give us a gradient of minus 2. So in this box, I'm just going to put that in right there. We have the gradient of minus 2 and the coordinates of 0, 0. So y minus y1, well, y1 is 0, so it's going to be y minus 0 equals, m is going to be minus 2, x, and then we're going to have x minus 0 for x1. So it's going to be y equals, well, minus 2x, and then we have this minus 2 multiplied by 0. Minus 0 is going to be nothing, so we're just going to leave it like this. So like I said, we're going to draw everything. So now we have this equation for the radius, and it's going to be y equals minus 2x. So now I've drawn the circle on here. So we have this tangent to the circle, and we have this bit here would be the radius, and this is the equation of the radius. So what I want to find out now is the coordinates of this point. So where the line of the radius meets a line of the tangent, and that is going to give us a point on the circle, and it can also help us to find out the size of this radius. So we're going to look for the radius and the tangent intersection point. We have y equals a half x plus 10 for the tangent, and y equals minus 2x for the radius. So I'm just going to find the x coordinate, I'm just going to make those equal each other. They're going to equal each other where they intersect. So we have a half x plus 10 is going to equal minus 2x. So I'm going to add 2x to both sides, which is going to give us 5 over 2x plus 10 equals 0. I'm going to subtract 10 from both sides to give us 5 over 2x equals minus 10. I'm going to multiply both sides by 2 to give us 5x equals minus 20. Then I'm going to divide both sides by 5. This will cancel out to give us minus 4. So the x coordinate is going to be minus 4. So if we want to find the y coordinate, we can choose either the point on the tangent, or we can choose the point on the radius. I'm just going to choose the point here on the radius. So y equals minus 2x. So when x is at the point of minus 4, y is going to equal minus 2 multiplied by minus 4, which is going to give us 8. So the coordinates where they intersect and the point on the edge of the circumference of the circle is going to be minus 4, 8. So I've added this minus 4, 8 to the graph here. Now I want to try and find the size of this radius, so from the center to the circumference of the circle. So I know that this line here at the bottom is going to be, well, it's going to be minus 4, but I'm just going to say it's a length of 4 units, let's say. And I know the height here is going to be 8, because this is the y-coordinate. So we have 4 here, 8 here. And now I'm going to use Pythagoras to get this, this length of the radius here. So the radius is going to equal 4 squared plus 8 squared. Sorry, the radius squared is going to equal 4 squared plus 8 squared, and that is going to give us 4 squared is going to be 16, 8 squared is going to be 64. So the radius squared is going to equal 80, and therefore the radius is going to equal root 80. So remember the equation of a circle is x squared plus y squared equals r squared. Now we know what the radius is now. We know the radius is root 80, so we can just put this in. We can put x squared plus y squared equals root 80. Let's just put this in brackets to keep it clear, all squared. Well, if we have 80, the square root of 80 all squared, these are just going to cancel out to 80. So we're going to have x squared plus y squared equals 80. And that is our answer to a really, really, really long question.